Hi, and welcome to another geometry gem where in this one what we're going to do is we're going to write a very simple algorithm to take a list of lines and then remove the ones that are duplicate. This is a very common scenario, for example, when we have geometry that is overlapping. So imagine this grid of rectangles, and if we were to explode all those rectangles into their individual lines, we will see that this line here is duplicated because it was coming from two different rectangles. This line here is duplicated, it's coming from two different rectangles, etc. So if we wanted a cleaner list of lines, we would actually have to go through the whole thing, compare them together, and remove the ones that are duplicate. So that's what we're going to do in this exercise. It's going to be very simple. The condition for this removal is going to be that we're going to compare the endpoints, all right? And we're going to see if those are similar. And for those situations where they are, we will be removing the duplicate line. This will not work. This will be a different algorithm than, for example, checking if a longer line is overlapping a shorter line on top of it, where their endpoints don't really match, even though they're overlapping and they're duplicate in a way. That is a different case, and which we're not going to treat here. And we're going to see that in this example, I'm going to first write how two lines combined can be compared in the simple case. And then I'm going to write another component that is going to take the whole list and it's going to do the cleaning process. Okay. This is going to be very similar to a previous geometry gem that we've done before, where we were removing duplicate points from a whole list. And we're going to base ourselves, some of the techniques that we're going to use here are going to be based on what we learned on that geometry gem. So I encourage you to check that one out as well. Let's get into it. All right, let's get busy. So before we start, let's obviously, as we typically do, let's think about the algorithm and the rules that we're going to implement here. And I have drawn these two lines. I want you to think of them as being perfectly overlapping, right? So what we're going to do is that the algorithm, we need to find a way to verify that these two lines are the same. This algorithm is going to assume that the endpoints of the line are the same. So we're not going to be looking at the situation where we may have a very long line and we may have like another line on top of it that is perfectly overlapping. This algorithm is not going to be able to do that at this point. We're just going to assume that they're perfectly overlapping, that their endpoints are the same ones. Okay. So one thing that we need to take into consideration is that what we're actually looking at here is the endpoints. So you might be inclined to say, well, one rule that I could find that I could do to remove these duplicate lines would be, well, maybe I can find the coordinates of the center of those lines, and if it's the same, then it's the same line. But that's actually not that actually doesn't work, because you could have this line here and this line here might have the same center, but they're not really, well, actually, those two are overlapping. That's a terrible example. But what about this line here and this line here, right? These two lines have the same center, but they're not really overlapping. They're not the same ones. So that's not a good rule. We need to find a rule to remove these lines, and that's going to be that we're going to compare their two endpoints, and if those endpoints are very proximal, they're very close to each other down to a tolerance value that we will specify, then we will remove those lines. But something that we need to keep in mind, and this is very important, is the fact that lines actually do have an internal direction. Okay, so we might be in a situation where the first line have this as the starting point, I'm going to call it 0, and has this as the ending point, I'm going to call this 1. And we might be in a situation where we're lucky and the second line also has this as the first point and has this as the second point. That could be a possibility. However, there might be a case where actually that's not how it works, and because of how those lines have been generated, which polyline they're coming from, or like which algorithm has created them, for some reason they might be overlapping, but they might be overlapping in opposite directions. So this one here might be the first point, and this here must be the second point, could be the second point or the ending point of that line. So we also want this algorithm to account for the fact that we want to remove duplicate lines that might be flipped against each other. Okay, so we're going to have to take that into consideration, and that's part of what we will do as we write the algorithm, okay? And then the only thing that we also need to keep into consideration is a similar thing to what we did when we did the remove duplicate points algorithm. When we search the list, so imagine we have, this is a list of lines. This is not lines. This is just a list of objects, right? Something that we need to keep in mind is that when we search through the list of all lines and we want to see if this line has a duplicate in the line, in the list, what we will want to do is we will want to go backwards and start searching from the last one, the second to last one, the third to last one, etc. Because if at some point, if at any point we remove one line from the list because it's duplicate, remember that these two lines will stack up. They will get one index number less, and therefore the list will change in size. So if we were searching this way and we remove the line, the rest of the lines remaining will change in index number, and it's a bit more tedious. So it's typically very good practice when you are searching a list that you want to remove elements from, to start from the end and remove elements backwards. Remove from the end to the beginning, because index numbers don't really change in that situation. If you want to learn more about that, please check my previous video on removing duplicate points, where I explain why we're doing that and the techniques involved in that. All right. So let's get busy and oh, sorry, I was in the middle of the drawing. So let's get busy and let's start implementing this. Let's start implementing this. Alrighty, so let's start. What I've done here is I have created a very simple algorithm where I have created a grid of rectangles, so a grid of squares. Okay, I have exploded all those squares, and then I have flattened that list. I'm exploding these squares because, as you can see, if I have one square here and I have another square here, this line is going to be duplicate when I explode them together. This line is going to be duplicate between the two cells. This line is going to be duplicate. So this arrangement here will actually have a lot of duplicate lines, except they will all be duplicate lines except for the ones at the boundaries. Okay? So if I explode them, I would get a tree-like structure that has 4 lines for each one of the squares, right? However, I am flattening that list because I want to end up with one list that contains all the elements on the same list, so that I can start looking at them and removing the duplicate ones. Okay? And then what I have done is I have gone here and I have created a C# script that is going to take that list of lines, is going to take a tolerance value for comparing the endpoints. I'm going to talk about that in a second. And then it's going to spit out a similar list of lines, but which is going to be clean. It's going to have all those duplicates removed. So we need to remember first to properly type the inputs of the C# component. So in this case, lines will be, for example, the type of the input will be of the type hint here, and will be of the type line, okay? And something that is very important is because in this case, I want to take the whole list of elements so that I can compare them together with each other. Then in this case, item access is not going to be good because I don't want the component to work with each one of the lines individually. I want the component to work with the whole list of lines together. So I need to double click here and set the access level to list. Similarly, for tolerance, I'm just going to choose a double value here. So I'm not sure why. Oh, so I'm just going to choose a double value here. Oh, and it's popping out on my other screen. So all right, so tolerance, where is double? Double. All right. Okay, and then as I double click here, you can see that my component now is taking an input of line objects, a list of line objects called lines, and then a double, which is the tolerance value for the comparison. Okay. And then what we're going to do now is we're going to write an algorithm that is going to go over each one of the lines one by one. It's going to compare that line to the rest of the lines. For each one of those comparisons, it's going to look at the endpoints, both the first one with the first one and the second one with the second one, or it's going to look at the first one with the second one and the second one with the first one. And if they are the same, then it will remove that list. It will remove that line from the list. Okay? Let's take a look at how we would implement that. Actually, I just had an idea, and I think it's going to be better that we first hone down on the simple case of having two lines and comparing them if they're duplicate. So let's do that first, and let's explain how that works. And then we can expand that into just taking a full list of elements and comparing them and doing like the whole comparison between the whole list. Okay. So what I'm going to do is I'm going to create a simple line here. Okay. I'm going to bring it into Grasshopper by setting this. Okay. So I'm just going to bring it in as a curve. So I'm going to set this curve, right? And then I'm going to use that as a duplicate. But also I'm going to create a second one. So that's going to go from the other end to the other end. Okay. So I'm going to bring that in as well by setting set one curve and then just setting the second one that I just created here. And then let's see if I actually chose the right ones. So if I say endpoints and I take this one here, then I should have the start points and the endpoints. Okay. And then if I compare with the other one, yes. So you can see that both lines have the same start point and the end points. They're just flipped. Okay. So that's going to be a good two lines to be compared. And then here, I just wrote a small component that takes line A and line B and compares them if they are duplicate. Okay. So also we may also want to just add a third line, which is not a duplicate one, to make sure that the algorithm works well. So I'm going to set this one here, okay? And this is going to be the one that is not a duplicate. These two are duplicates, but this one is not. So here I'm going to choose line as the input data. Here I'm also going to choose line as the input data. And first of all, I'm going to try with the same line twice, okay? And then here the component is going to tell us if these two lines are duplicate or not. All right? Okay, so let's give it a try. So here I'm going to write the code to compare these two lines if they're together. And if you know me already, you know that I like building code that is reusable. So basically here in the main script, I'm almost just not going to write anything. What I'm going to do is I'm going to write a function here that given two lines returns true or false if they are duplicate. Okay, and then in the main component, I'll just call that function. I do that because then I really like copying and pasting code between my components and my functions. So if I create a function that does that, it will be much easier to reuse in other places. Okay. So I'm going to create a function here and I'm going to call rduplicate. And then this is going to take a line object called A. And then it's going to take another line object called B. And it's going to return a Boolean value whether if these two objects are duplicate or not. All right. And then, so for the time being, I'm just going to say return false. Because I'm just going to write placeholder code and I want to make sure that everything works. So this is working right now. And then here, what I would do is I would write a Boolean variable dup, and this is going to be equal to the result of saying, are these two lines duplicate, and passing line A and line B. And then, and actually, you know what? Actually, I could just do here, I could just do duplicate. Sorry. I could just pass this directly to the outcome, duplicate to the output directly like this. Oh, I'm really... Okay, so the output is this component. The duplicate is going to be the result of calling this function that is going to take line A and line B, what comes as an input, and it's going to call this function and it's going to return the outcome, which is that Boolean value. Now, okay, so now let's write some code to make sure that line A and line B are the same. So we said that what we're going to do is compare starting points, and then if they're not, then compare, if they're not the same, compare start plus end points. So we're going to compare them cross. And if that is not true, then we will not, and if those are not equal, then this line will not be a duplicate. So what can we do for that? Well, so a typical thing that a typical tendency could be to say, well, how can we compare these 2 points if they're equal? Can I do the following? Can I say if the line A, if the start point, which is called from, equals b dot from, then these 2 elements must be the same, all right? However, that is actually not a good technique to use, because in computer programming, when you compare objects like this, you're typically not comparing their XYZ values. The computer doesn't really know that points, like for example from, the computer doesn't really know that they have XYZ points, XYZ coordinates, and that equality between those 2 objects means that XYZ coordinates should be very similar, okay? So that's not how it works. What we need to do is we need to manually check that their coordinates are actually, their XYZ points are actually very similar or equal, okay? So what I'm going to do now then is I'm going to create another function that is going to be called RDuplicate, and this is very interesting. RDuplicate, or I'm going to call it RSimilar, all right? And what this function is going to do is going to take a point 3D A and another point 3D B, and then it's going to return true or false whether if those 2 values, those 2 points have similar coordinates, all right? And I'm saying similar because our here returns true if coordinates of points are equal, all right? A tendency for us would be, let's create a variable and say, are these guys similar? And then what we do here is we compare the XYZ coordinates. And we could say, my way for comparing them is going to be a dot x, is the coordinate x equal to the coordinate x of b, and is the coordinate y equal to the other coordinate y, all right? And is a dot c equals to b dot c. So, and I'm going to just write a parenthesis. We don't really need this parenthesis, but it's just a little better visually to understand what I just wrote here. So our tendency could say, well, we can just compare the values of x and x for the 2 points, and the values of y and y for the 2 points, and the values of z and c, and see if they're equal. And if they're not, then we return true or we return false. However, this is not really a good technique either, because it happens that due to the nature of floating point numbers or double numbers, it turns out that we can't really compare numbers that have a decimal part with a straight equal sign, because depending on where those numbers are coming from, they may actually have like very, very small differences in the precision in their decimal part, and the computer will have a really hard time comparing them. And it may actually happen that 2 numbers that for us, they look identical, even to their whole precision, all the decimal numbers, their internal representation as a double may actually not be exactly the same. And we may just have points that are actually very, very close to each other, but if we compare them with the equal symbol, it will return false, okay? So actually, what we typically do is that instead of comparing whether if these 2 values are equal, what we do is we compare the distance between them, and if that distance is below a particular threshold that we typically call tolerance, then those numbers, we assume that they are the same, all right? So we don't really compare for equality. So what we do is we compare for similarity. If those 2 values are close enough to each other under a particular threshold. So how will we go about that? Well, first of all, let me add a third parameter here that I'm going to call tolerance. all right? And tolerance. And then I'm going to set that. It has to be a double. Okay, and then I'm just going to plug this in here. Now I have here my tolerance, and then I'm going to pass this to the function tolerance. I'm going to compare lines based on a tolerance value, and then here I'm going to compare tolerance or D, whatever. And then let's say that this function takes a value that is called tolerance, for example. All right. The way to compare this would be the following. What I would do is I would say, are these points similar? And what I'm going to add here is the result of, first of all, I'm going to subtract the coordinate x minus the coordinate x of the other point. I'm going to subtract those two. And I want to know how far away they are. But before I do that, I need to make sure that the value that I compare is not the actual subtraction, is the absolute value of that subtraction. Because it turns out that if A is slightly bigger than B, we get a positive number. But if B is slightly bigger than A, then we will get a negative number. And therefore, the comparison will not be great. So what we want to do is we want to take the absolute value of this difference so that we know that this value is always going to be positive, and then see if this value is less than the tolerance that we have specified. So if the absolute value of their difference is less than tolerance, and I'm going to copy and paste the same thing for y in this case, so that's going to be y. My God, this is going to be y, and then if this is going to be and, if this is going to be c, and if this is going to be c, if these three conditions apply, if the x coordinates are less than a tolerance, and if the y coordinates are subtracted are less than the tolerance, and these are less than the tolerance, then this whole thing will be true, and therefore the 2 points will be similar. Otherwise, they will be false. If one of these fails, then this whole expression will be false. And then here I can return similar. Okay? So this is actually a fairly cheap way of comparing points, but it's also a fairly good one because we don't have problems with precision. We can control what for us duplicate means, how far away the ends must be, and then yeah, it's a very common way of doing it, basically. All right, so let's actually make sure that this works well. First of all, so I'm going to cancel this out, and I'm going to cancel this out for the time being. And here, just for the sake of experimenting, I'm going to say duplicate is going to be equal to, are these points similar? And then I'm going to take from the starting point of line A, I'm going to take the starting point of line B, and I'm going to take tolerance. I'm going to pass tolerance as the value. I'm going to run this, okay? And we can see that indeed, for the same curve that has been passed to these two, both the starting points of those two lines are the same, okay? And even if I reduce the tolerance value, you see, when it goes back to 0, it's not working, but if I make it a very small value, it works. Now, if I were to plug in this curve here, right, the one that is totally off, this should be changed to false, okay, because the starting points are not the same. And if I were to plug in the one that is the same but inversed, so the same but in a different direction, it should give me false as well because the starting points are not the same. The starting point and the end point of them are the same, okay? All right, so it looks like our similarity comparison for points is working. So that's good, all right? Now, let's use this to compare the two lines here. So I'm going to say I'm going to say, remember what we discussed? We are going, oh, I don't know what I've done. Sorry. So remember what we said. We're going to compare the two lines and we're going to say these lines are going to be duplicate if both the starting points and the end points are the same, or if the start point and the end point of one and the end point and the start point of the other one are the same. Otherwise, they're going to be different. So how can we do that? So we can say, first of all, let me compare things. If the starting point, of the two are the same, okay? If the starting point to the same and the end points of the two are the same, so 4 and so 2 and 2, if these two are the same, okay, I'm actually going to write it in the same line. I'm actually going to write it here. If these two and are the same, I'm making a mess here. If this is true, okay, so if the starting points both are under the same tolerance and the end points are both under the same tolerance, okay, or I'm going to compare the opposites. So I'm going to say if the starting point of line A equals the end point of line B and the end point of line A equals the starting point of line B, all right? If these two things are true, then I want my function to return the value of true. Otherwise, if they are not, I want to return the value of false. Okay, this can be written in multiple ways, and I think I have a problem with the curly brackets. I think I'm putting way too many curly brackets somewhere. Yes, I'm missing these curly brackets here, and then here, here, this one. Yeah, I'm missing another set of yeah, I'm missing, yes, here. Okay, and I'm still getting an error. What is going on here? Line A and line B doesn't exist. Oh yeah, sorry, because this is A and this is A and this is A and this is A and this is B and this is B and this is B and this is B. Okay. And then tolerance. Okay, so I'm just going to rename. So this is going to be line A. This is going to be line B, and this is going to be tolerance. It doesn't really matter. Okay. All right. So, and then the output is going to be this one. Okay. So let's see if this works. So we're going to compare the one line against itself. So this should be true, which it is at this point. All right. Now I'm going to compare this line with the same one that was flipped. This should be true, and it is true. And I'm going to compare the one line with a line that is totally somewhere else. So that's going to be somewhere here. And this one is false. Okay. All right. So it looks like our algorithm to compare two lines if they are duplicate is working right now. All right, so now let's see how can we take this code and then how can we take a full list of lines and compare them with each other and then remove the duplicates. Let's take a look at how that works. Okay, so let's go back to where we were before. I'm going to go back to the component where I was going to write my algorithms to remove the duplicate lines. I'm going to double click, and you can see that I have already copy pasted the functions that I created for my simple case of comparing two lines. Okay, because I will use that function when comparing all the lines together. And as I said before, I like writing reusable code. So I'm going to write, instead of writing the algorithm for comparisons here, I'm just going to wrap it into a function so that I can move it and paste it between other components, just like I did with these ones here. Okay, so what I'm going to do is I want a function that, given a list of lines and a tolerance value, returns another list of lines without the duplicate ones. So therefore, the return type is going to be a list of line objects, right? And then I'm going to call this function, for example, remove duplicates. This is going to take a list of line objects called, for example, lines. And the fact that these lines and these lines have the same name is purely coincidental. It doesn't really matter. And then I'm going to also pass in a tolerance value. Okay. So how are we going to write this algorithm? Well, first of all, I probably want to create a list of lines, an empty list of lines that I'm going to call clean. And I'm going to initialize it to a new list of line objects that is going to be empty. All right. And then what I would like to do is I would like to take these lines and I would like to iterate over all of them, compare them together, and those that are duplicate get removed from the list. If you remember from my previous video in which I was doing removing duplicate points, I explained how the way we're going to do this is by looking at each one of the lines, each one of the objects in order. So I'm going to start with the first one. I'm going to start with this first one, and then I'm going to compare it with the last one and the second one and the third, this one. I'm going to compare them in order backwards. And if I find one that needs to be removed, then all the elements will reorder in numbers, but that will not affect how I keep checking the next one, the next one, and the next one. And the second one that I will choose will be, okay, now I'm going to compare this one, and I'm going to compare it against this one, this one, this one, this one. So I'm going to always start one by one and compare against the rest of the list backwards. All right. If you want to know more about why this has an advantage, please check my other video. All right. So we're going to do that. So what I'm going to do is, first of all, I'm going to create a for loop that goes over all the lines on the list. So for int I equals 0, I is less than the number of lists in the lines. So lines, lines dot count, and then I plus plus, and then for this one, I'm going to take the line that I'm going to compare. So this is going to be lines. I'm going to take this one. All right. So now what I would like to do is I would like to compare all of these against all the other ones. And actually, now that I'm thinking about this, instead of starting with an empty line here, what I would like to do is, instead of starting with an empty clean list here, what I would like to do is I would like to start by copying this other list here. Okay, and I can't really do that. Okay, give me a second here. Yes, so before we start doing anything, I actually, instead of starting from a clean line, instead of starting from a clean list, what I would like to do is I would like to start from a copy of the original list of lines that has been given to the function. So create a copy with all those lines and start removing them. I want to do that because it's typically not good practice to actually change the inputs that are coming into your function. And because this is a list of lines, this object, the list of lines, will be passed by referenced. So if I change it inside of my function, it will also be changed in the original source code that is calling that function. And that is typically not considered good practice unless it's purposefully what you want to do. In Grasshopper world, it doesn't really matter because Grasshopper works with references and values a little different, and anything that comes into a component is already passed as a copy anyway. But it's typically not good practice. So I wouldn't want, if we were to copy this code somewhere else, it may actually affect the source, and that's something that we don't want to do. So what I'm going to do is I'm just going to manually use a for loop to copy all these lines one by one and to copy them into the clean list. So I'm going to start with a list that is a pure copy of the original list, and then I'm going to start cleaning them out. So I'm just going to write copy original list. So I'm going to say for int I equals 0, I is less than lines.count, and then I plus plus. I'm just going to the clean list, I'm going to add a copy to the original lines. I'm going to run this, and it looks like I'm getting an error. Yes, I'm getting an error because I am not returning anything from this function yet. So I'm just going to, as a placeholder, I'm just going to return the clean list right now. Okay? All right. And then the next thing that I'm going to do is I'm going to clean up the list of duplicates. And that's what I was doing before. So I'm going to say, first of all, I'm going to create a for loop that goes over all the elements on the list. Remember, I'm going to start with the first one, the second one, and third one, and compare them against the rest of the ones on the list. So I'm going to say for int I equals 0, I is going to be less than, in this case, it's going to be the amount of elements on the clean list, because as that list starts getting less and less elements, we need to account for those elements being removed. So I'm going to say, let me first take whichever line I want to compare. So that's going to be from the clean list. It's going to be the first one, the second one, the third one, whatever. And then what I want to do is I want to compare that one. I want to compare that one against all the other ones that are on the list, but starting from the back. Okay. So what I'm going to do is I'm going to create here another nested for loop for int j equals however many elements are on the list minus 1. All right, so it's going to start by the last element of the list, remember? And that's going to be how much elements we have? Minus 1. All right, then I'm going to say j has to be greater than 0. Not in this case. J has to be greater than the number of the list, the number that of the line that we are comparing. Okay, so for example, if we're comparing line number 2 with all the other ones, then j, when we go backwards, has to be greater than the value of 2. If that doesn't work, then then we're done comparing. So j has to be greater than I, and then j has to go backwards. So instead of increasing, has to go minus minus. And then what we're going to do here is then I'm going to take the other one, and I'm going to say that's going to be j. That's going to be the line that is in j. Okay? So what I'm going to do now is I'm going to say dup, and I'm going to store the result of r duplicate, and I'm going to call this function with the first line, all right, the second line, and the tolerance value. So what I'm doing here is I'm taking the line that I'm comparing, and I'm taking the other line that I'm comparing, and then I'm checking if they are duplicate with the tolerance value that has been given to this function. And if they are duplicate, if dup equals true, then what I need to do is I need to remove from the clean lines, I need to remove this element here. So how do I do that? I just type clean and then remove at. So remove whichever element is at position with an index number. And I know that the index number of the other line that I want to check is going to be j. All right. So I want to remove from that list, I want to remove a j, the object that is at position j. And I think that's actually pretty much it, because like I'm going to keep checking with this for loop. I keep checking more and more lines. This algorithm will work for if I have like many lines that are duplicate. And here I just keep checking one by one. And as this list decreases in elements, it has less and less, then I will approach the end of the line. And then whatever that is, we're basically good to go. So let me see if that works. So I should be, oh yeah, well, I haven't really called that function. So let me say clean lines should be equal to remove duplicates. All right. And then lines and then tolerance. And then let's see if that works. Oh, all right. So it looks like in the original list, I had 100 elements. And on this list, I have 59 elements. So it looks like I have removed basically, how many? How many is that? Sorry, 60 elements. I have removed 40 elements. Okay, that sounds about right to me. I'm not sure what could we do to compare this, but it works. But it works well. Okay. Okay, one quick thing we have discovered is that before, when I was trying to copy the list by passing lines here, I thought I couldn't do this because I was getting an error. But it turns out that the error was coming from somewhere else, and it turns out that this is a valid way of copying the list. So instead of having to iterate through the list, I can actually just copy it by when I create the new list, passing in another list to create a shallow copy of that list. So actually this code works, and it's easier and faster than having to iterate manually with a for loop over the two lists and copy one and copy the other. Okay. Okay, so I think with this, we're ready to wrap this up. So we have written an algorithm to remove duplicate lines under the condition that we were checking the endpoints. So this is going to work for lines that have similar endpoints, but perhaps not for lines that are only partially overlapping. Okay, that would be a different algorithm. So with this, we're in. So if you like what you saw, please remember to subscribe, check notifications for more videos on geometry gems, computational design, learning how to code, etc., etc. Thank you very much.